that follow that we get him out on to speak to you. Michael's going to speak to you next about a critical part of the story, which is design and building. And he comes from a brilliant practice, Grimshaw. He's been involved with one of the most recognizable and most visited buildings in the UK, probably in Europe, the Eden project down in Cornwall, driven by a rather brilliant owner-developer, Tim. And he's now attached also to the Green Building Council. And he's going to tell you about building and design.
Right, well, thank you for that introduction. I was very interested by the previous talks, and what I'm going to try and offer is a kind of architectural perspective on what we can do to tackle climate change. And it's often the case that green technology is considered to be commercially unattractive and has to rely on philanthropy and so on. But we actually believe that there's a very strong commercial case for green technology. And we find that by actually taking a leading role in green architecture, we're able to retain and attract some of the best staff around. But the commercial case that I really want to talk about is the one that we offer to our clients. And a lot of our inspiration actually comes from nature. I think there's absolutely huge potential to be gained by treating nature as mentor and actually looking for solutions that offer factor 10 or even factor 100 savings. And by that I mean achieving the same outcome, but with a 10th or even 100th of the resource input. So the first project I want to talk about is the Eden project. And this was conceived as a visitor attraction, a showcase for global biodiversity, and it was to mark the turn of the millennium. Now, for us, it was an absolute revelation, seeing what just an amazing storehouse of design ideas and inspiration nature can be. And we turned to nature at all different stages of the project. And I guess in a way it's not surprising, because when you think about it, nature's pretty good. It's had a long R&D period, 3,800 million years, in fact, and most of the faulty products have been withdrawn from the marketplace. So for the Eden project, this was the site we had to deal with, and it was a hell of a challenge. This site was a china clay pit, and it was actually still being quarried when we were trying to design it. And we couldn't wait because the program was such that we had to get on with it. And as an architect, you often have to deal with some pretty big uncertainties, but you can normally rely on the ground staying where it is. Unfortunately, we didn't have that, so we just had to press on. We had to come up with an idea that would work regardless of what the final ground levels would be. And the idea that we came up with was this one, where we modeled this in 3 dimensions on the computer. And the idea was that we would arrange this string of bubbles, and the diameter of the bubbles could be varied to provide the right growing height in the different parts of the greenhouse. And then by arranging those on a kind of necklace line, we could get that to fit in with the natural topography. And I don't know if you can see, but just running around the outside of that bubble diagram, you can see a red line. And that's where we actually intersected this bubble model with a ground terrain model. And then by cutting away everything that was below ground, we arrived at the first image that looked something like a building. And we knew from Buckminster Fuller that the most efficient way of actually structuring a spherical surface is with a geodesic structure. The next challenge was to find an alternative to glass, because glass is way too heavy, the unit sizes are far too small, and so on. So we were familiar with a material called ETFE. It's a high-strength polymer, or as our client called it, cling film with attitude. And the way you do this is that you put it together in 3 very thin layers, and you weld it around the outside, and then you inflate it. And that's what gives it its rigidity. And you can see that's how it looks in the finished form. And I want to try and convey what I think we achieved with this scheme, because not only was it 1/3 of the cost of a conventional glass solution, but it also ran on 1/4 of the amount of energy of a conventional building. And this ETFE covering was about 1% of the weight of a double glazed solution. So that's a factor 100 saving. And because that was so light, there were knock-on savings on the structure and the substructure and so on. And I did a calculation towards the end of the project, working out the weight of the superstructure. And I worked out that the weight of the superstructure of that climatic enclosure, the humitropics biome, was actually lighter than the weight of the air that it contains. Lighter than the weight of the air that it contains. And now that we've been through it, we actually know how we could make it much lighter still. So that project shows how by looking to nature for inspiration, you can actually produce a form of structure and enclosure that is radically more efficient in terms of its energy efficiency and the energy required to build it. Now, the next project is called the Eco Rainforest. It's another big greenhouse, but on this one, the challenge was to make it carbon neutral. And our inspiration came from two sources for this project. The first one was this painting of Charles II being handed a pineapple, and the second one was Siberian sturgeon. Now, some of you are probably sitting there thinking, what is this eco nutcase on about? But have faith, and all will become clear. So we had another very challenging site. This time it was a landfill site, and it was the first time I'd actually been to see a landfill facility. And it really is, as the fashion world might say, it is just so last century. This idea of taking all these valuable minerals and resources out of the ground, turning them into very short life products, and then dumping them back in the ground. And we didn't have to worry about that. It was a big site. We could have just ignored it and built something alongside it. But we wanted to respond to this in some way because it was such a striking aspect of the site's history. And we were aware of this little project at the time. It's called the Cardboard to Caviar project. And it was done by the Green Business Network in Kirklees and Calderdale. And I'll just quickly explain how this works. In their area, they had quite a lot of posh restaurants. And generally speaking, this is the way restaurants work. You get a very linear flow of resources, a lot of highly packaged food stuff going through, and a lot of waste at the other. Most of that goes to landfill. Now, what they did, the really clever bit, is what they did with the cardboard, because they were paid to collect that. They then shredded it and sold it to equestrian centres as horse bedding. When that was soiled, they were paid again to collect it, and they put it into worm recomposting systems, which produced a lot of worms, which they fed to Siberian sturgeon, which produced caviar, which they sold back to the restaurant. Which is nice because it's a bit like a form of alchemy, turning a very low-value material into a high-value material and earning money on the way. But it's also identical to the way that natural systems work. Natural systems are all closed loop in terms of energy and waste and so on. So we wanted to try and do something as clever as that with our project, if we could. We also thought very carefully about what had worked well on the Eden project and what we might want to do slightly differently given another opportunity. And the thing that everyone seemed to relate to and get excited about was this idea of the rainforest. Everyone, all age groups from school kids up to saga louts, could get excited about that. So very early on, we fixed on this as the concept, that we would try and recreate this sample of Amazonian rainforest on our site and do that as fully and faithfully as possible. And we thought very carefully about how to get the maximum visitor educational benefit and visitor drama from it. So we thought it'd be great if you could come in at high level, get a view out over the journey you're about to go on, maybe come in next to a thundering great waterfall so that all your senses are engaged by the heat and the steam and the sound and so on. And then with lightweight walkways running through the treetops, you could start to explore all the different vertical layers of the ecosystem. And with a whole range of animals that would complete the picture about this being all about ecosystems and the importance of understanding ecosystems. Now, this is where the pineapples come in, because we were aware that one of the challenges was to make this a carbon neutral scheme. And there was a time in English history when there was a real craze for growing pineapples. And if you had a fresh pineapple on your table, then that was an absolutely massive status symbol. And there were all sorts of ingenious ways of growing these that were devised. And this was the one that we got really excited about. It's the pineapple sheds at Heligan Gardens. And the way that these work is that you have these, you have a south-facing glass roof, and then you have stepped beds on which they would plant the pineapples. And then on the south side and the north side, there were these double walls into which they would load fresh manure. And just the heat from that manure decomposing was enough to get the air temperature up to 75 degrees. And that was the first time that anyone had grown a carbon-neutral pineapple in this country. And of course, what this did is it reintroduced the whole idea of waste, because if we were to move away from a conventional approach to waste to a more enlightened approach to waste, you can see that a lot of those waste streams, like paper, can be turned into insulation. Quite a few of those waste streams can be turned into building products. But the really key one is this one. About 60% of what goes into landfill is biodegradable. So if that was put into a biodigester, that would produce a lot of heat, which could be the carbon neutral source for our heating system. So that was the first sketch we produced. Very similar in many ways to the pineapple shed's south-facing glass roof. We'd build up these walls out of rubble waste, so just from the sun and this kind of heat storage of these massive walls, the building would be self-heating for a lot of the year. But then during the colder times of the year, these in the walls, these are the vertical biodigesters, so you could draw the heat off those to heat the building. And then in plan, we kind of elaborated the plan shape to get more wall surface area into it, because the walls are the radiant surface. And all those circles around the perimeter are the vertical biodigesters. And then looking at in section, you can see quite a lot of the ideas I was talking about early on, coming in at high level next to a waterfall, circulating around the perimeter, exploring all the different layers of the ecosystem, ending up at the forest floor. And then in the walls, those are the biodigesters. So on the outside, rather than trying to force glass into a very organic shape, we've really sort of celebrated its crisp, planar quality. And we've done quite a bit of work on this project since we did that stage, looking at the economic benefits of this. And you can see that just based on the value of energy, the value of compost, and the money that you can get from landfill tax, this would generate an income of 11 million a year. And that's based on landfill tax at £20 a tonne. It could well go up to £50 a tonne or even £100 a tonne. So a huge economic potential there. And that represents a return of about 6% before you've got a single visitor through the door. We also think this has got other potential applications, for instance, as commercial greenhouses, so that we could grow more of the kind of foodstuffs that we've got used to, but without flying them in from all sorts of parts of the world. So with this building, by looking at the way that natural systems work and taking inspiration from the pineapple sheds and so on, we've come up with a scheme that could radically reduce the carbon footprint of the foods that we use, and also show how you can do something very creative with waste. You could build that whole building out of waste and run it on waste. Now, the third and final project that I'm going to talk about is, this is a water project, and this is based in Las Palmas, where we were asked to do something to improve the appearance of the dock area. Las Palmas in the Canary Islands, most of the towns on this peninsula, got a very nice side there with the beach and the hotels and so on, and then an absolute dog of a side with a container port and a shopping centre by another British architect that I won't mention. And now the kind of cornerstone of any regeneration strategy has to be some kind of, I think, has to be some kind of inspirational building. It needs some kind of a magnet. And here we go. Now, I'm sure you're all familiar with the Namibian fog basking beetle. But what you might not know is that this little chap has found a very clever way of creating its own fresh water in the desert. And the way it does that is that at night it comes out of its hidey hole, and because it's got a matte black shell, it radiates out to the night sky, and its shell becomes cool enough to form a condensation surface, so that when the moist breeze blows in off the sea, you get these droplets of water forming on its shell, and then it tips its shell up, and the water runs down to its mouth, it has a good drink, and then it goes off and hides before the sun comes up. It's fair to say it's not a great quality of life, but you know, it's a clever trick, and I respect that. And for this project, we collaborated with a brilliant chap called Charlie Payton, who came up with this thing called the Seawater Greenhouse. That's the first example. And this is a greenhouse intended for coastal arid regions. And the way it works is that on the seaward side, you have this whole wall of evaporator grills, and you trickle seawater through that. And when the onshore breeze blows through, it picks up a lot of moisture. And then the roof has two layers of polymer, and the lower layer is fairly opaque to infrared, which generally speaking plants don't need. So that cuts out a lot of heat from the greenhouse. There's about 10 degrees C below ambient inside, which is a much better growing environment for plants. But then the really clever bit comes at the leeward end, where you have a whole wall of plastic tubes, thin-walled plastic tubes. And once again, you pass seawater through that. And because those are relatively cool, like the beetle's shell, when the moist air hits that, you get a lot of condensation forming. and it actually creates 5 times as much fresh water as it needs for the plants to grow. So using virtually no energy, just a tiny amount of pumping energy, it turns seawater into fresh water. And we worked with Charlie Payton on the Las Palmas scheme, and we realized that Las Palmas has quite a lot of advantages. Firstly, it's got a very steady wind direction all year round. It's also pretty sunny, so that if you were to use fairly simple solar panels, you could heat up the water that's going into the evaporator part so that you'd get more water evaporating. And then, because the Canaries are volcanic, they've got very steep sides. And with a fairly economical sea pipe, you can get down to deep sea water, 1,000 meters below the surface. The water is at 8 degrees C. So if you put that through the condenser part, and you put those things together, then you've got a very powerful desalination effect. And because we're architects and we like doing things that are fun, we decided to turn this into something sculptural. So we took these banks of evaporators and condensers, and we put these wind flaps on to control the wind speed and optimize the performance. And then we turned it into this backdrop to an outdoor amphitheatre. And what you're looking at there is actually a carbon-neutral desalination plant, but it'll also be the biggest outdoor amphitheatre in Spain. And I don't know what you think, but I think that's a hell of a lot more fun than a big, ugly portal frame shed with massive pipes burning shitloads of carbon and so. Thank you. And in terms of its position in Las Palmas, it's intended to be a bit like, say, the Statue of Liberty or the Sydney Opera House, in that it's something that welcomes your arrival into Las Palmas and hopefully intrigues people and gives a sense of identity to the island and so on. And so now I just want to try and draw together 1 or 2 conclusions, really. And I guess the main conclusion is that I do think this idea of using nature as mentor works. With the Eden project, that project actually transformed the way that people see Cornwall. And it contributed £500 million to the local economy in the first 3 years. It's also the only scheme to have ever been made a World Heritage Site during the lifetime of its designer. So, you know, although there are some very worrying times ahead in terms of climate change and so on, I really do think that there's huge potential to be gained from looking at nature. And for every problem that we face, whether it's creating energy, finding fresh water, or manufacturing materials in a benign way, there'll be examples from nature that we can follow. And I'd be prepared to bet you that all those examples from nature would be closed-loop, solar-powered, and completely non-polluting. So I think the message is, if you go about it the right way, you can actually make more money and radically reduce your impact on the environment. Now, I'd love to be able to tell you what camel nostrils and sea cucumbers could do for your business, but that'll have to wait for another occasion. Thank you for listening.
Great.